In this video, we are going to learn the process of converting a quadratic function from standard to vertex form using axis of symmetry. So we have two functions here. F of x is equal to ax square plus bx plus c. It is in standard form, right? And f of x is equal to a times x minus h whole square plus k. That is given to us in vertex form. So whenever a function is given to us in this standard form, from this standard form we can convert it into vertex form by making use of this axis of symmetry. Now let us consider a function f of x is equal to x square minus 6x plus 10. It is given to us in standard form like ax square plus bx plus c. Alright, from this standard form we are trying to go to this vertex form. So now in the first step, let us try to find what is the y-intercept. So in order to get this y-intercept, I should substitute x is equal to 0 in the given function. So f of 0 becomes 0 square minus 6 times 0. Wherever x is there, I am substituting 0 plus 10, that is 0 minus 0 plus 10. So your f of 0 is equal to 10. Hence your y-intercept is 0, 10. So on this graph, this is the graph of the function f of x equal to x square minus 6x plus 10. You can see that when x is equal to 0, the value of y is 10 and it is being intersected on this y-axis, right? This is the y-intercept we have now. So this is your step 1. In first step, we figured out what is the y-intercept. Now in the second step, we have to find, is there any other x value for which the y value becomes 10. So here we are seeing that for this, on this particular line here, y value is 10. All the way at this other end also I can see the value y is 10. What is the x coordinate for this? We have to find. I can see that it is on the graph, it is like 6, but algebraically we are going to get that x value for which y becomes 10. Okay, so in order to find that x value, I have to take x square minus 6x plus 10. That is that function f of x I have written here, and I am looking for the value of the function f of x to be equal to 10. So that's why this is 10 here. So remember, in the second step, I am equating this function to be equal to the y-intercept value, that 10. This 10, I am writing it down there. Just remember that way. Now, how do you solve this? To find the value of x, the first step is take away 10 on both sides. So your 10 got cancelled, leaving behind x square minus 6x is equal to 10 and 10 cancelled, so that is 0. Now x squared minus 6x, I am saying that is x times x, that is 6 times x. So x is a common factor between these two terms, so leaving behind one x here and other 6. So x times x, x square, x times 6, 6x. Everything is fine. Now what is the next step? I'll write x is equal to 0. That is the product of these two factors is 0, hence x will be 0, or x minus 6 is equal to 0. Solve by adding 6 on both sides. So that gives me x is equal to 6. So these are the two values, x is equal to 0, comma x equal to 6. Those are the two values of x for which y becomes 10. See, this is a 0 and the other thing is a 6. This coordinate here, x value 6, y 10, and over there x 0 and y 10. X value 0 and y is 10. Now this completes step 2, where we have just solved this function and got the two values of x. Now in the third step, I have to find this axis of symmetry. Right? What is the axis of symmetry? I have to find. How do you find the axis of symmetry? In order to find this axis of symmetry, that is a line which is halfway between these 2 points. So find that x value which is exactly halfway between 0 and 6. That is nothing but the midpoint. Using the midpoint formula you can do, or just directly find the average of those x values, because the y value is just the same, 10 and 10. So average of x is 0 plus 6 over 2. That gives me 6 divided 2, which is equal to 3. So this x is equal to 3 is your axis of symmetry. Axis of symmetry, in short, I can say AOS, which is x value is equal to 3. I'll draw a line also for our clarification. This is the line we are talking about. This line is the axis of symmetry. You are seeing that x value is 3 here. 1, this is 1, 2 and 3. At x equal to 3, you have that axis of symmetry. You know that this is exactly, it divides the graph into 2 equal parts. That's the thing. Now you got axis of symmetry, and in the fourth step, we are going to find the vertex. We are looking for the vertex. So vertex is this point, right? That is the turning point. We have to find the coordinates of that particular point. It is the vertex I'm looking for. Symbolically, we write it as vertex is equal to h comma k. This x coordinate, x value is nothing but h, that is 3 you already have. Now we have to find k. So in order to find that k, go back to that function f of x is equal to, we have x square minus 6x plus 10. So in this function x square minus 6x plus 10, we are going to substitute 3 for x. You have x is equal to 3. So f of 3 is equal to 3 square minus 6 times 3 plus 10 gives me 9 minus 18 plus 10. So that is 19 minus 18 is 1. F of 3 is equal to 1. That f of 3 is nothing but the y coordinate. So x coordinate is 3 and y coordinate is 1. And when you substitute here in the vertex, the same thing, I'll call it as h value, that is 3, and the k is 1. So we have the vertex now, that is 3, 1. We see it here in this graph. x value is 3, when x is equal to 3 and the y is 1. This is 1, so 3, 1 is the vertex. Now in the next step, that is step 5 or the last step I think, we have to change this function x square minus 6x plus 10 into the vertex form. Almost everything we have now, right? We see that a is equal to that 1 only, that a value is 1. We have this vertex, okay, that is h is equal to how much? 3, and k is 1. I'll substitute them now. F of x is equal to 1, a is 1, times x minus, see this x minus is there in the formula, so just write down minus sign. This is the h and that is k, I already have here, x minus 3 whole square plus k, that is equal to 1. That's all. This is the vertex form of the given quadratic function x square minus 6x plus 10. Now what are the 5 steps that are involved in finding this from standard form to vertex form of the given quadratic function? Let us quickly go back and see. The first step, find the y-intercept, and in the second step, find those two values of x, that is one is for x equal to 0 and what is the other x value for which y is the 10, which is y-intercept. Now third step, find the axis of symmetry, which is the average of the two x values here, 0 and 6. That is the axis of symmetry, and substituting that axis of symmetry in the given function for that value of x, you end up getting the y value, right? And that x and y makes a vertex, just 3, 1, and this vertex substituting in this formula, we have your final answer. Okay, now instead of going through this long process, there is a shortcut, but the thing is you need to know the formula for the axis of symmetry. The formula for axis of symmetry is x is equal to negative b over 2a in this standard form of quadratic function. Okay, now identify what is your a and b. In this you have a is equal to 1, that's 1x square, so a is 1 and b is equal to negative 6. Therefore, what is axis of symmetry? The x value equal to negative. B itself is negative 6, so I'll have to write negative 6. So in the formula I have a negative sign times that negative 6 over 2 times, say that is 2 times 1. So negative of negative 6 gives you positive 6 over 2. So 6 divided 2 is nothing but 3. Therefore, your axis of symmetry x is equal to 3. Now, find the value of this function, value of the function f of x for x is equal to 3. That is, substitute 3 for x. Let us substitute 3 for x. Again, I'm writing over there. Alright. Now, f of 3, x equal to 3. This is 3 square minus 6 times 3 plus 10. That is 9 minus 18. 6 times 3, 18 plus 10. That gives you 1, right? 9 plus 10 is 19, 19 minus 18 is 1. So f of 3 is equal to 1. When x is a 3 and y value is 1, that is your vertex. Okay, vertex is 3, 1. So this 3 is your h and 1 is a k. This is 3, k is 1. The value of a is already 1 you have. So my function f of x is converted into vertex form by replacing a with 1, then x minus h, that is equal to 3 whole square plus k is equal to 1. So from standard to the vertex form we changed it. Okay, that's the shortcut, easier way. The thing is, I need to know that the axis of symmetry is equal to negative b over 2a. Let us look at one more example following the same rule of axis of symmetry. I'll use this to find my vertex form. Okay, what is the value of a? In this case, a is equal to 3, b is equal to 12. So x is equal to negative, in the formula I have a negative sign, negative 12 over 2 times 3. So negative 12 over 2 times 3 is 6. Gives you x is equal to 12 divided 6 is a 2 with a negative sign, negative 2. Now substitute x equal to negative 2 in that function. Let us do it. X is equal to how much? Negative 2. So f of negative 2 is equal to 3 times negative 2 whole square plus 12 times negative 2 plus 14. I can directly use calculator instead of simplifying. Just let me show you how to use calculator and get our result. Okay, I'll clear it up here. 3 times negative 2 square plus 12 times negative 2 close parenthesis plus 14 is equal to 2, right? That is the 2 here. So f of negative 2 is equal to 2. So for x is equal to negative 2, the value of y became positive 2. That is your vertex of the function f of x. This is h and that is k. Go to the formula of vertex form of a quadratic function. F of x is equal to a times x minus h whole square plus k, where this a is equal to 3. I'll replace 3 for a. H is negative 2. We have to be careful here. H itself is negative 2 and k is positive 2. Okay, so f of x now changes to 3 times x minus h is negative 2, like this, x minus negative 2 whole square plus k, that is 2. Further, I can rewrite it as 3 times x minus -2. So negative of negative becomes positive 2. X plus 2 whole square plus 2. That is the vertex form of the given quadratic function f of x. Right? Very simple. Just find the axis of symmetry. This axis of symmetry substituted in the function f of x to find the value of k, that is this x and y gives you the vertex h comma k. Go back and substitute in the vertex form of the quadratic function. Now last example, you have some negative sign here. Let us see. A is equal to -2, b is equal to 7. So axis of symmetry, x is equal to -b over 2a. I'll substitute my values. Negative b is 7 over 2 times a, that is 2 times -2. Right? So x is equal to, this is like -7 over 2 times -2 is -4. So in my quotient, I can cancel off negative and negative cancels off. You can just write 7 over 4. So axis of symmetry is a 7 divided 4. Now substitute in the given function. Now that becomes f of 7 over 4 is equal to -2 times 7 over 4 whole square plus 7 times 7 over 4 minus 5. So f of 7 over 4 is equal to, we will enter these numbers in calculator. Okay, so I'll have 2 here, then parentheses, I'll go to fraction, that is 7, 4 underneath, come out of the fraction, close the parentheses, then square plus 7 times, that is parentheses, alpha and y equal to, that is 7 over 4, come out, close, then minus 5, hit enter. So you have 9 over 8, right? That is 9 divided by 8. So that is the y value, x and y. That is nothing but your vertex 7 over 4, comma 9 over 8. Vertex, that is h and k. In the formula, f of x is equal to a times x minus h whole square plus k. I'll substitute. A is equal to -2. Right, a is -2, h 7 over 4, k 9 divided 8. So my vertex form is going to be f of x is equal to -2 times x minus 7 over 4 whole square plus 9 over 8. If you want, even you can change this into decimal form, and you can rewrite into decimal form, that's fine. we have fractions here, right? So the process is the same. Find the axis of symmetry by using this negative b over 2a, substitute, find the value of y, that x and y together gives the vertex, substitute, and that's your answer. Okay, all right, thanks for watching.